Okay, so let's see if we can do better by applying a different neural network architecture. So here we'll see the first modern deep learning neural network architecture called a convolutional neural network, or CNN. As I mentioned earlier, in deep learning, what we do is we add more layers, and through the additional layers, we can recognize more and more abstract concepts in the image. So convolutional neural networks go through these multiple layers and basically start from the image, which is a set of pixels, and then through each layer find more and more abstract concepts in there. So in the first layer, there might things like just simple lines, horizontal and vertical, then more complex shapes, and then recognize different parts of the image, like in the face, recognize eyes, lips, ears, glasses, and so on. And then finally, in the output layer, make a decision, for example, classify into male or female. So what we're going to look at is how to build a network that can analyze images like this. And one new thing in this network here is a new kind of layer that we haven't seen before, and that's a convolution layer. What this layer is doing is applying an operation called convolution, which is basically a filtering step on here the input that we have as image. So the way it works is just a simple matrix multiplication. So here, this is part of an image, 3x3 portion that we obtained. And then we have a filter here. And then we just multiply these two together, 0.6 times 1 plus 0.2 times 1 plus, and so on. And then this filter gives you, as the output, 2.3. Likewise, this image here, same filter, will give an output of minus 2.3. So what we had here is a filter of 3 by 3 by 1. 1 because it's just one dimension. So remember earlier we had 3 for the 3 different channels, and here it's just for now a black and white image. So what is this good for? Well, that's the idea of the convolution layer. It has these filters that can recognize or emphasize certain features in the input. For example, here we have 2 filters that can emphasize horizontal lines in an image or vertical lines in an image. So when you process the input image, what you do is you take this filter and then basically you slide it over the image from beginning to end. I'll show this again in another example in a minute. So you apply this filter on each subset here, and then you get a new filtered output image. And depending on the filter, the output image has certain changes, like highlighting edges, highlighting horizontal lines, highlighting vertical lines, and then later on in the network, it will highlight more abstract features. So we have the input. In this example here, 64 by 64 by 1, so it's grayscale image. We have 2 filters. Each filter is 3 by 3 by 1. And what we get now in the output is, again, images of size 64 by 64. But now, because we have 2 filters, in the next layer, we're going to have 2 images. So it's 2 dimensions here in the tensor. So how do you apply this kind of layer in Keras? So the input layer in this example is just like before, except now the size is 64 by 64 by 1 for a grayscale image. And what we apply here is a 2D convolution. 2D because it's a 2-dimensional filter. So we have 2 filters of size 3 by 3. I'll explain these next 2 parameters on the next slide. Stride and padding. And then we apply this filter on the input layer, this one here. So you might wonder, here, we didn't actually have to define the filter, like give me a filter for recognizing horizontal lines or vertical lines. Well, that's the cool thing about deep neural networks. They will learn these filters by themselves. So the network will over time by itself learn how to highlight and represent certain features in the image. And that's the big difference to the old style machine learning architectures. So in old style machine learning, people came up with these filters by hand to extract something useful out of the image and then use this as the input to the machine learning algorithm. That's also what we've done, for example, in classifying questions. Remember, we extracted feature from the question, like how many capital letters are there and a few other features. So you manually had to identify the features, just like people used to have to manually identify filters to get something out of an image. And the really big thing about neural networks, what makes them so cool and so useful, is that they learn these representations by themselves. They learn the filters by themselves. So I still have to explain to you what is strides and padding. So these are two parameters you can define on those filters. So stride is just the step size. How many steps do you apply? How do you move this filter at a time? So here, what you see here is the input image. That's the blue one here. So the input image is 5 by 5 by 1. The kernel, the filter, is the gray one. And then we generate the green one, which is the output image. So if we have a stride of 1, means we are moving the filter one step at a time. You can also select a stride of 2, so move it 2 steps at a time. And then you can see that the output will become smaller. So kind of a compression of the image. So that's the stride parameter. The second one is the padding, and that's defines what you do with the filter at the edges of the image. So remember, the image itself is 5 by 5. Now we could say, okay, we start just in here, but then you can see we would be able to apply the filter only 1 times, 2 times, 3 times. So the output would be a 3 by 3 image and not a 5 by 5 image. And it would be very hard if there is something interesting at the edge of the image, like a line directly at the edge, the filter wouldn't be able to pick this up. So very often what you do is apply padding. So basically here we apply one step around the image. The values are going to be set to 0, but this allows us to apply the filter on the complete image. And from the input also get a 5 by 5 output image. Okay, time for a small exercise to make sure you understand how these filters work. Please go through the first task on the worksheet, post the results on Moodle, and I'll see you back in the next part.